Today we've got a rather immaculate Realistic TRC2002 mobile, complete with factory mic and a decent sized power lead. Now, I've only seen one of these once before. However, we've got the full manufacturer's service manual in line with all the Realistic stuff, really comprehensive. And I've made myself a chart so we can do the adjustments, including the VCO. Now for those of you who don't know, these were made in Korea for Tandy Corporation by GRE, that's General Research Radio, and they're the people who were manufacturing the scanners and for the shortwave receivers such as the DX160. So they're actually quite good, and this chassis is used in the Realistic TRC3000 base station. We've actually got two of those in as well, so they're going to be a forthcoming attraction as well. So even got the brackets. I'll make sure that we don't misplace the bracket, and I'll just take the screws out and we'll take it from there. Returning to the Realistic TRC2002, the first thing is the VCO. Selecting channel 40, putting your test meter. I've got the earth to the chassis on this, and a test meter to prod to pin 17 of the synthesizer IC, which is IC number 1. And going into transmit now, we should have 5 volts. Well, we've got 5.6. Now, it's coil T8, transformer 8. Now this is still sealed, and that to me is okay, subject to the next test. And the next test is to make sure that on channel 1 that it's 3 to 4 volts. So we're now staying in receive. We've got 3.84 volts. That's fine. So it's very slightly high on transmit, but it's in lock, and receive on channel 1 is within that 3 to 4 volt parameter. So we're not going to alter it. So I'll just go through that again. It's IC1, it's pin 17. It's a 20 pin device. Pin 1 is the one with the dent. So we're fourth from the other side. And you're going to transmit on channel 40, and it should be around about 5 volts. And then on receive you're going to channel 1, and it should be between 3 and 4 volts. And that's what the factory service manual says, and that's fine. This set's pretty immaculate. It doesn't look like it's ever been opened up, to be honest. Manufacturing date of 1982. So our next port of call is to go to transformer 9. So I'm now going into transmit. At the moment it's got 2.8 watts coming out of it. The manufacturer says these should produce between 3.4 to 3.9 watts. So I'll check transformer 9. Moving over to transformer 10, which has got 2 cores. Now we move over to the coils. These are hexagonal ones, so using the, is it the green tool for these? It is the green tool. Always use these plastic type of trimming tools. These are readily available places like eBay even. They don't have to be from the wholesalers like we would use. They come in sets of goodness knows how many. Likewise from the electronics wholesalers, don't use Allen keys. So just check L5. Moving from L5 now to L4. Back to the other tool. Incidentally, we're now at 3.2 watts. And then we move on to L3. So it's back to the green plastic trimming tool. And then finally we're looking at T11. And that now comes out at just a fraction over 3.5 watts. And I say that, as I said many times before, that's 3.5 real watts on this test set. So that's well beyond the 4 good buddy watts that you'd normally expect out of a CB. So that's fine. That's within space. Now let's move on to the RF meter. Now the RF meter is variable resistor 4 if we need to adjust it. And conveniently they're labelled on the printed circuit, and it says PO for power output, and it is VR4, which is there. Now we'll just see what the meter says. Good grief, can you read a meter like this? It's right into the middle of the transmit power reading. There's a red zone, and it is central in that red zone, so that's absolutely fine. If it needed adjusting, as I say, it would be VR4. Now, low power, when I switch to low power, and there's a little switch at the back on these, it should be 0.4 of a watt. It isn't adjustable, but if it's out of tolerance by a long way, the service manual tells you how to calculate a different fixed resistor. So I'm now going to check that. Should be 0.4. It's 0.38. That's fine. So we'll check the radios on frequency, and it should be 27.79125. It's 27.79121, so I don't need to adjust that. It's CT1 next to the 10.7 reference crystal. It's quite a high quality trimmer capacitor. I've not seen one this high quality in a CB radio. Mind you, these weren't cheap sets. It's very basic, but they were $69.99 at the time in 1982. Right, we'll get the little oscillator out. I'll switch the camera on so you can see this, and hopefully not my shoulder. Right hand oscilloscope. It's doing 1.8. So we'll just turn that up to 2.5. And that is spot on with the whistle test as well, and the wah-low test. Good. So it was, do you know, I don't think it's ever been touched since it was manufactured. So that's it. That does cover the transmit and the VCO for you, and I'll join you on the receive side of the adjustment of this radio.